Yes, a sealed flask with a capacity of 2 decimeter cubes. Decimeter cube stands for what? 2 liters. So therefore there is a sealed container whereas its volume is 2 liters. It contains 11 grams of propane. What it is consisting? 11 grams of propane it is having, whereas this particular flask is so weak that it can sustain a maximum pressure of 2 megapascals. 2 megapascal stands for what? Mega stands for 2 into 10 power 6 pascals. Up to this much of pressure it can sustain. Above this, at this or above this, at and above, this flask will be getting opened. Then the maximum temperature that it can burst is. To solve this, we should go for the minimum temperature at which the bursting takes place, implies its energy should becomes equal to the energy of these 2 megapascals related 2 liters related energy. As we know from the ideal gas equation, PV is equal to what? nRT. PV is equal to nRT stands for, this is gas present inside the cylinders related N into R into T should becomes equal to given conditions related, that is given megapascals related pressure into corresponding volume, because it is a sealed container implies what? Its volume should becomes equal to always remain same and constant. So therefore the maximum pressure that it can sustain is 10 power 6 megapascals. If I convert that one into atmospheres, every 10 power 5 pascals will becomes equal to 1 bar, whereas every 1.01325 bars will becomes equal to 1 atmosphere. This is pressure and the corresponding volume is 2 liters. This particular PV product, this particular energy summation should becomes equal to N into R into T, the minimum temperature where up to where it can sustain, where from it begins to undergo explosion. Whereas number of moles, if I go for propane is having molecular formula, that is structural representation like this. This is CH3 followed by CH2. The formula is C3H8. C3H8 stands for 36 plus 8. That will becomes equal to 44. Whereas the weight of propane is given by 11 grams, weight by molecular weight, number of moles into R value is 0.0821, because these of all are present in liters followed by what? Atmospheres. Now we have to calculate the minimum temperature, to what an extent it is going to be stable, where from the explosion going to be started. So this will becomes equal to 10 into 220, 20 divided by 1.01325 into this will becomes equal to 4 divided by 0.0821 should becomes equal to the temperature in Kelvin. And this corresponding value is found to be, that implies here the calculation results, that is 80 divided by approximately 80 divided by 0.0821, that resulted as, here in this it is given as 2 megapascals and it is into 2. So therefore this will becomes another 2 becomes, this will becomes another 2. So that resulted value will becomes, so the minimum required temperature becomes, T will becomes 160 divided by 0.0821 into 1.01325. Whereas this is found to be equal to 1923 Kelvin, and if I convert that one into degree centigrades, that becomes as 1923 minus 273 kelvins, approximately this is 0 implies this is 5 implies this is 650 Kelvin and 650 degree centigrade. This is 650 degree centigrade.